Betelgeuse is so big that if you were to place it in our own solar system, it would stretch to the orbit of Jupiter.
Supernovas are a big, giant, dramatic end to a star's life.
The James Webb Telescope has been uncovering mind-blowing revelations in recent weeks. But brace yourself for this discovery that could jeopardize the very frontier we cherish and pose a perilous thought to our home planet. Picture this: a team of daring astronomers embarking on an exploration of the unknown with the James Webb Telescope directing its gaze towards Betelgeuse, a celestial giant illuminating our night sky. And then, in a jaw-dropping moment, a peculiar signal picked up by the JWST immediately sends shockwaves through the scientific community. And this signal is no cause for celebration, it forewarns an impending explosion. But what does this mean for Betelgeuse? Is it truly on the verge of a cataclysmic event, and what repercussions might Earth face? Join us as we delve into the extraordinary account of the James Webb Telescope's detection of gravitational waves coming from Betelgeuse. Eager with anticipation, the scientists eagerly awaited the extraordinary sight that awaited them in space as JWST and LIGO joined forces. But what they uncovered in the data left them utterly astounded. A gravitational wave had been detected by JWST and LIGO, originating from the constellation of Orion, where the radiant Betelgeuse resides. Betelgeuse, a vivid crimson star perched upon Orion's left shoulder, falls into the category of a semi-regular variable star, flickering sporadically rather than with regularity. This mammoth star, positioned approximately 425 to 650 light-years away, boasts an immense stature. A colossal size stretching 1,400 times that of our Sun, and a luminosity outshining it by a staggering 14,000 times. Every 430 days, during Betelgeuse's cyclic dimming, dark blemishes materialize on its surface, reminiscent of the sunspots seen on our Sun, yet far grander in scale. What intrigued scientists was the unusual dimming currently observed on Betelgeuse, raising speculation that this aging star is nearing the end of its stellar existence, on the brink of a supernova explosion. The detection of gravitational waves from this region has sparked concern and deep contemplation among astronomers, pondering whether this long-awaited cosmic event is imminent, and if so, hoping it transpires in the approaching days. When that fateful moment arrives, the semi-regular variable star will dazzle our skies, shining as brightly as the moon even in daylight. Yet, upon revisiting the drawing board to scrutinize further data, scientists stumbled upon telltale signs indicating the luminous red supergiant Betelgeuse is poised to burst. This revelation emerged from meticulous analysis of data collected by NASA's James Webb Telescope, Hubble Space Telescope, and other observatories. The deductions drawn by scientists and astronomers point to an astonishing conclusion. The fiery giant Betelgeuse experienced a catastrophic outburst years ago, shedding a significant portion of its visible surface. In the aftermath, a titanic mass ejection ensued, hinting at an impending cataclysmic explosion, leaving the scientific community awestruck. However, this extraordinary behavior displayed by Betelgeuse is entirely unprecedented in the realm of normal stars. While our Sun occasionally releases fragments of its delicate outer atmosphere, known as the corona, through a phenomenon called a coronal mass ejection, Betelgeuse's case is mind-bogglingly extreme. It expelled a mass 400 billion times greater than a typical ejection. Can you believe that? Thanks to the utilization of JWST, scientists and astronomers have also uncovered that this colossal star is gradually recuperating from this catastrophic upheaval. Although ongoing observations surround this star, the perplexity surrounding these occurrences is undeniable, even acknowledged by Andrea Dupre from the Center for Astrophysics in Cambridge, Massachusetts. In a statement, she admitted Betelgeuse continues exhibiting highly unusual behavior at present. Its interior appears to be undergoing a sort of rebound. While scientists and astronomers are not entirely bewildered by these events, they have gleaned valuable insights from this phenomenon. The newfound observations furnished by JWST offer glimpses into the mechanism of mass loss in dying red stars. Scientists have learned that these stars shed mass when their nuclear fusion reactors dwindle before they culminate in explosive supernovae. The extent of mass loss significantly influences their destiny. Yet with Betelgeuse shedding a substantial portion of its constituents, can we not infer an imminent explosion? This is precisely why scientists and astronomers harbour deep concerns. Presently, Andrea Dupre is assembling the intricate pieces of the star's enigmatic behaviour before, during and after the eruption to construct a coherent narrative of an unprecedented convulsion in an aging star. This comprehensive account will involve fresh imaging and spectroscopic data collected from the Stellar Robotic Observatory, the Tillinghast Reflector at the Fred Lawrence Whipple Observatory, the Shell Spectrograph, and the James Webb Telescope. Dupre emphasized the crucial role played by JWST and Hubble's data in unraveling this mystery, stating, "We have never witnessed such an enormous ejection of mass from a star's surface before. We are witnessing the real-time evolution of a star." The possible cause of the titanic outburst in 2019 could be attributed to a massive convective plume, stretching over 1 million miles, surging up from deep within the star. This tumultuous event generated shocks and pulsations that forcefully expelled a portion of the star's photosphere, resulting in a significant cool surface region. Covered by the dust cloud formed by the cooling piece of the photosphere, Betelgeuse now faces a struggle to recover from this injury. Weighing several times more than our Moon, the fragmented photospheric piece swiftly propelled itself into space, cooling down and transforming into a dust cloud that obstructed the star's light visible to Earth-bound astronomers. At present, the supergiant's once consistent 400-day pulsation rhythm appears to have vanished, albeit possibly only temporarily. Dupre proposed that the star's interior convection cells, responsible for driving the regular pulsations, may now be in disarray, akin to an unbalanced spinning washing machine. The recent data from TRES and Hubble spectra suggest that the outer layers of the star may be returning to normal, but the surface continues to exhibit a bouncing motion as the photosphere reconstructs itself. While our Sun experiences coronal mass ejections that expel tiny fragments of its outer atmosphere, astronomers have never before witnessed such a substantial portion of a star's visible surface being forcefully expelled into space. Therefore, surface mass ejections and coronal mass ejections may be distinct phenomena. Betelgeuse's immense size is such that if it were to replace the Sun at the center of our solar system, its outer surface would extend beyond the orbit of Jupiter. NASA's James Webb Space Telescope may have the capability to detect the ejected material in infrared light as it continues its journey away from the star. Scientists and astronomers, while utilizing the James Webb Telescope, made further discoveries about Betelgeuse. Analyzing historical records and descriptions, they determined that the supergiant star transitioned from yellow-orange to red approximately 2,000 years ago. Betelgeuse, a red giant star, signifies the stage where stellar bodies expand after hydrogen depletion, engulfing inner rocky worlds when our Sun undergoes a similar process in the distant future. Stellar color changes provide insights into age and mass, with more massive stars like Betelgeuse transitioning from blue-white to red through a yellow-orange phase. By examining ancient texts, including those by Chinese astronomer Sima Qian, researchers confirmed Betelgeuse's color transformation. These findings enhance our understanding of star life cycles. From these specifications, one can conclude that Betelgeuse at that time was in color between the blue-white Sirius and Bellatrix and the red Antares, University of Jena astrophysicist Ralph Neuhauser, who is on the team behind the discovery, said in a statement. Neuhauser and his team employ a process known as terra astronomy, which combines physical research with interdisciplinary studies encompassing natural philosophy, languages, and history. According to Neuhauser, the insights gained from this backward glimpse in time yield significant advancements and outcomes. Historical observations are deemed indispensable in resolving several astrophysical challenges. Beyond color alterations, Betelgeuse has recently undergone notable changes, captivating astronomers' attention. Termed the Great Dimming, the star experienced an unprecedented decline in brightness, plummeting to approximately 35% of its usual luminosity throughout 2019 and 2020. The dimming commenced in December 2019, with Betelgeuse gradually regaining its brightness in the subsequent months. This enigmatic reduction in the red star's luminosity sparked a flurry of proposed explanations, with some astronomers speculating it could be indicative of the star contracting prior to an explosive event. Scientists finally deciphered the mystery of the Great Dimming using data collected by the James Webb Telescope and the Japanese weather satellite Himawari 8. The satellite's infrared and optical observations unveiled that the dimming occurred due to a combination of the star cooling and the formation of a dust cloud around it. With this perplexing phenomena solved, it is now confirmed through historical investigation that Betelgeuse is expected to go supernova in approximately 1.5 million years, as stated by Neuhauser. Furthermore, the transition of Betelgeuse's colour from yellow-orange to red over the course of 2 millennia, in conjunction with theoretical calculations, indicates its mass to be 14 times that of our Sun. Mass serves as the primary factor governing the evolutionary path of stars. However, some scientists are suggesting that the presence of gravitational waves does not sufficiently confirm the imminent explosion of the star. For instance, Salvatore Vitali, a physics professor at MIT collaborating with LIGO, points out that the detected waves originating from the direction of Betelgeuse do not definitively indicate their source as Betelgeuse itself. Additionally, although neutrinos are typically emitted by a star prior to a supernova, this has not yet occurred. Moreover, Betelgeuse continues to emit light in the night sky, albeit significantly dimmer than usual. Considering these factors collectively, Vitali concludes, speaking solely on his own behalf, that the gravitational wave candidate is unlikely to be directly linked to Betelgeuse. There is also a possibility that the detected signal is not a gravitational wave. Its characteristics do not match any known mergers, leaving the cause of the detection a mystery. Although waves can sometimes result from Earth's own noise, this is unlikely in this case. False alarms like this typically occur only once every 25 years. While this may seem like favourable odds against a false alarm, Vitali points out that other sources of gravitational waves, such as a neutron star and black hole mergers, have false alarms occurring once every 1,000 or 1 million years. 1 in 25 years is decent, but not extraordinary, commented Vitali. So, what is your opinion? Will Betelgeuse eventually explode or not? Share your thoughts in the comments section below.